All right, so for the last lesson of the semester, it's series and parallel circuits. So um, the first idea we're going to talk about is circuits that have resistors in series, or everything's in series. So a series circuit only has one path for electricity to follow. So this red arrow going around is the current, and that represents is represented by I. This is our battery symbol, and then we have two resistors, and they're all on the same path, or loop, or line, however you want to describe it. But one thing is right after the next thing, right after the next thing. So if you remember the analogy with water going through a pipe, there's basically just one pipe that starts here at the battery and makes its way all the way back to the other side of the battery. So all the current that leaves this battery and is forced through the circuit goes through every single piece. That's one of the parts that you should be aware of. So to find the total resistance in a series circuit, all you have to do is just add them together. So if you had two resistors, you would just add them together. If you had three in series, you would keep adding and adding and adding. We already mentioned the current is the same for all of them, so the total current is equal to the current that goes through the first piece and the second piece and the third piece, again, because there's only one pipe. And then another rule that comes out of this setup is the battery voltage is equal to the voltage across each piece added together, so voltage of 1 plus voltage of 2. I'm going to explain this a little better with what's called Kirchhoff's loop rule. So I have some pictures down here that we'll go through. So Kirchhoff's loop rule is based on conservation of energy. So the energy of this whole circuit comes from the battery. And the energy that it gains across the battery, or potential or voltage that it gains across the battery, it has to lose that amount of energy on its way back to the other side of the battery. So a loop is just an independent path to take its way, or to make its way around the circuit. So if you look at this small picture down here, this is one loop. So in this diagram, we have a battery here, which is a 9-volt battery. So the voltmeter reads 9 volts when I measure across it. So that's a gain of 9. That's what I'm saying down here. And then I'm going to just read each of the individual voltages across these other resistors. So if I take the voltmeter and I hook up the two probes to the 10 ohm resistor, that's a 3-volt loss. So it has 9 to start, and then it loses 3 across the 10, and then it has to lose the rest across this 20 up here, and that would be 6. So 3 plus 6 equals 9, and that's basically it. So as you go around the loop, you have to get back to 0. That's the idea. So if I gain 9, I lose 3, I lose 6, and that works out mathematically according to Ohm's law still. So we're going to go through an example here and see how you do. So given the picture to the right, this picture, and we know this is a 40-volt battery, and this is a 20-volt, or I'm sorry, this is a 20-ohm resistor, and it's got 8 volts across it. We want to know how much voltage is across this 80-ohm resistor. So using that loop rule, we would talk about, I'm going to type it instead of writing it. So we know we have 40 in gain. We're trying to find the voltage of this 80 piece. And then we know that the other voltage drop here is 8. So if we are solving for V, you would just solve by 40 minus 8, which is 32. So 32 volts is what's used up or across this piece. So 32 and 8 will get you back to 40. So just to give you some other pictures, so that was all in series again. But the next type of circuit we're going to study is a parallel circuit. So looking at this, and this is actually a combination circuit because it's got multiple pieces. So first off, the first question here is how many loops are there in this picture? So again, a loop is just an independent path. So I can start here and draw. So it can go like that, and maybe I call that loop 1. So it starts here at the battery, it goes through the 80, it goes through the 10, and it comes back, and that would be 1 loop. And then I could do a second loop. It goes through the 80, and it goes this other path, so across the 40, and then all the way back. And I would call that loop 2. So there's 2 loops in each one of those. So the next thing, just kind of erasing some of that work so you can see a little bit better. So it says, what is the voltage across this 40 ohm resistor? So this is 110 volts here. Looking at this voltage across, I put the probes across this resistor, so that's got 100. So if this is 110 and this drops 100, how much is left for the 40? So it would be, again, typing it out, it'd be 110 equals 100 plus whatever this other voltage is for this 40. So, all right, 40. And if you just think about it mathematically, that means that V40 has to be 10. So 10 volts is what's left over. So you could hopefully figure out the current through this bulb. It's just using Ohm's law, so V equals IR. So if the voltage we just said is 10 volts, and we know that the I is what we're looking for the current, and the resistance is 40, you just have to solve for I. So the I equals 10 divided by 40, which is 0.25 amps. And then if you wanted to do power, you can use the power equation, so P equals IV. So this is a review from last lesson. So the current we just got is 0.25, and the voltage we just said was 10 volts in this 40 ohm bulb. So 10 times 0.25 would be 2.5, and that would be watts. So so there you go. You can see how, like, finding this one little piece, and you know 2 out of the 3 of Ohm's law. You can figure out the third one, and then you can use the power equation once you know I and V. Doing the same kind of work over here for the other, what's the voltage across the 10 ohm bulb. So let's think about this loop. So if we do this loop here, so again, this is 110 for the gain of the battery, and again, the voltage, the voltmeter didn't change here, so this is still 100 of a drop across the 80 ohm resistor, and then we want to find the voltage across the 10 ohm resistor this time. So again, it's still going to be 10, so that's what's left over. So let me just type it out. So the voltage that's left is equal to 10, and that has to go through here. The current in that bulb, again, you would just do the same kind of thing to solve for current. So if I kind of use Ohm's law, and I'm just going to switch out the numbers. So it would be 10 equals I, and then this resistance is only 10 in this light bulb. So 10 equals I times 10, so it would be 10 divided by 10, which would be just 1 amp. So you got 1 amp of current going through this bulb, and you got 0.25 going through this one. So that should make sense, because which one has more resistance? The 40 ohm light bulb. So that means it'll have less current, and the one with less resistance should have more current. That's what Ohm's law is about. If we look at the power equation, we'll do P equals IV. And if you plug in I as 1, and the voltage we said was 10, so 1 times 10 is just 10, and it'd be watts again. So if we compare the powers here, the bulb here, this 10 ohm bulb, is more powerful than the 40 ohm bulb. And for looking at this picture, how can you tell which one's more powerful? It just comes down to the brightness. So another kind of idea that is useful is that the power is equal to the brightness. As you can see, this 10 ohm bulb is putting out more light than the 40 ohm. So that's why we know that, okay, we did this right. So I'm going to pause there and see where we're at time-wise. All right, so I'm going to finish up series circuits, and then we'll get to parallel in another video. But in this example, it reads a 9-volt battery is connected to 4 resistors, and it gives you the values for those for R1 through R4. You're supposed to find the total resistance of the entire circuit, the total current going through the entire circuit, and the voltage and current that is in each of the individual resistors. So kind of looking at that, you have a 9-volt battery, and then those 4 resistors. This is all series because there's one path. So the first thing is to just go back and kind of remember the rule for resistors in series, which you're just adding. So you're just going to add all of these individual resistances up. So it's 2 plus 4 plus 5 plus 7, which gives you 18 ohms. Once you get the once you get the total resistance for the whole circuit, and you know the total voltage of the battery, then you can just use Ohm's law to solve for the total current. So moving down another line here. So the total voltage equals the total current times the total resistance, just Ohm's law. And then I would just plug in the values that we have. So 9 equals I times 18. So we're going to solve for I, and you should get 0.5 amps. So we got 0.5 amps is the current that leaves the battery and starts making its way around the circuit. And if you imagine this traveling through, all that 0.5 amps has to make its way through R1 and then R2 and then R3 and then R4. So just by knowing that this is a series circuit, we know the current in each one is all the same. So the current for every, there's a typo there, for every one of these individual resistors has a current of 0.5. Sorry for that typo. So the total current is 0.5, and that means the current that it goes through each piece is also 0.5. And then you know the current and the resistance for each piece, so the voltage isn't that hard to calculate. You're just going to use Ohm's law again for each individual voltage. So for the first one, we do V1 equals I1 R1. So I1 is 0.5 because that's the current that goes through. And then R1 was 2 ohms. So we take a half of 2 and you get 1 volt. So you keep repeating this process over for the different values. For I2 and R2, you get 2 volts because it's 0.5 times 4. For 3, and then for 4. So those are the individual voltages across each piece. If you remember the loop rule, it says whatever you gain going across the battery, you should lose going back to the other side of the battery. So that's summarized in this rule here. So if you add all these up, so you gain 9 going across the battery, and if you add up all of these pieces, 1 and 2 and 2.5 and 3.5, you get 9 volts. So that's a nice way to kind of check and do the work and make sure that, hey, I did this right. So similarly, I didn't ask you for any power calculations, but you could do really similar work for power. You would just do P equals I of V. So you could just use P equals I times V for each individual one. So if you wanted the total power, you use the total current and the total voltage. So it would be like 4.5 watts. And then if you wanted the individual ones, like for P1, the power used in the first resistor, it'd be I1 times R1. And then for 2, use the 2 I2 and V2. And you would just go through that and be able to work that out. And it works out the same way. So there's series circuits. The next video will be on parallel.